So good morning, ladies and gentlemen. We've already started the day off with our warm-up. We've got all of those submitted, and we are going to get into our goldfish activity today. We start off with a warm-up with a number of questions pertaining to observations, because observations are extremely important. I noticed when I was making some observations that in the pond that I have out behind my house, the goldfish that I have swimming around in that pond, I noticed that you can observe them breathing. And I noticed that specifically every time they take a breath, they kind of move their mouth. And then the operculum on the side of the fish kind of moves out. Well, the weird thing about the goldfish at my house was that when I looked at them, it was kind of a really cold morning, and the water temperature had dropped quite a bit, and I was actually afraid that my goldfish was dead. It was laying there kind of straight up, looked normal, but wasn't moving at all, and its mouth was hardly moving whatsoever. And then I came into school where the temperature inside of the school was a little bit warmer, and I observed the fish tank. And I noticed that the fish that were inside of the fish tank, their mouths were moving a lot quicker. And their operculum on the side of their body, side of their head, was moving a lot quicker. And it got me wondering, what relationship, if any, might exist between the temperature and this rate of what maybe we would call breathing that goldfish were having. So I want to open up a conversation right now about how we might go about testing for that, and what types of things we might need to account for if we were running this experiment to try to identify if there was a relationship between temperature and the movement of the fish's mouth and or gills or operculum. How do we go about testing for that? Was that you, Emily?
I said I kind of have a story about this.
Okay, I want to hear your story.
So, like, one time, my mom had a fish. She brings this up every time we talk about fish. But she had a fish, and she was cleaning out its bowl, and she put, like, way too cold water in it. So it, like, floated to the top, and it, like, essentially froze. So then she was, like, freaking out, and then she put, like, boiling water in it, and then she, like, fried her fish.
Oh.
So she, like, was trying to counteract her ability by making it warmer, which, like, could have worked, but she did it, like, way too fast, and it, like, shocked the fish's system.
Wouldn't putting the cold water shock the fish, so it was just shocked? So
yeah,
you just
that was pretty much it. It was just, like, kind of shocked at the top, and it was, like, cold. So it was, like, swimming really fast around its bowl and trying to warm up. And so my mom was, like, trying to warm it up with hot water, and she, like, ended up frying it.
Interesting. So what I'm hearing you say is maybe there's a range of tolerances for temperature of goldfish.
Yeah.
Like maybe if it's too cold, they can't survive, and maybe if it's too warm, they can't survive. And so maybe we need to figure out the range of tolerance before we perform this experiment to make it an ethical experiment. We don't want to. We aren't into just killing the goldfish. We want to make sure that we're doing this ethically. So maybe what we need to do right now is we've got our laptop sitting in front of us. Maybe we need to figure out what is the range of tolerance for a goldfish, so that at least we fall within that range. So why don't we have somebody do that? All right. What other things might we need to account for in setting up this experiment? Current water temperature might be important. Very true. Or if not concerned about current temperature, maybe we need to at least allow the fish to sit in that temperature for a little while, because if I drop them from warmer temperature into colder temperature, maybe they're still doing what they would have done in the warmer temperature for a while. Okay, Avery? Maybe the size and the age of the fish is important. That might be something that is important for us to account for. Absolutely. Do larger fish tend to have more mouth movements versus smaller fish, or vice versa? Yes, sir?
It's 60 degrees Fahrenheit and 70 degrees Fahrenheit.
So the range of temperature should be between 60 and 70 degrees Fahrenheit.
Are these fancy goldfish?
No, these are like the Meyer specialty, like 25-cent feeder goldfish. I'm pretty sure they mass produce these just for the purpose of feeding other things.
They're not common to human things.
Huh?
They're not common to do both things.
Yeah, I don't know. Maybe I should have grabbed the scientific name off of the tank at Meyer, so that then I knew specifically which one it was. Maybe I need to go back and get that information, because I don't have that information right now.
Maybe you could just go to 60 to 74.
I'm sorry, what?
60 to 74.
You came up with another temperature? In between what and what?
60 and 74.
60 degrees Fahrenheit and 74 degrees Fahrenheit. I know the other day that my pond was a little bit cooler than 60 degrees Fahrenheit. So maybe this is like optimal temperatures, like where they survive best. And maybe we can go a little bit below that and a little bit above it, but maybe we don't want to go much. So maybe they'll be okay up to like 80 degrees Fahrenheit. And maybe they'll be okay down to like 55 degrees Fahrenheit. But we really don't want to push those boundaries much farther than that. Okay? Sound like a plan? All right. So our question, as a reminder, is what relationship, if any, exists between temperature and the rate of breathing that these goldfish are exhibiting? Yes, sir?
In colder water, there's more oxygen.
Oh,
Or dissolved oxygen.
that's a great point. He brings up something from our salmon in the classroom stuff that we learned a couple years ago, that when we have colder water, we do have more dissolved oxygen. And so if we have colder water, maybe that plays into the rate of movement of the mouth, just because there's more dissolved oxygen in cooler water. Interesting. So if we're setting up this experiment, what do we need to do? What do we need to account for? If you're setting up any experiment, what do you need to account for? Oh, variables. Okay, let's talk about variables. There are two different types of variables, right? Does anybody remember what those two different types of variables are? Okay, we do put those variables on the x and y axes on a graph, absolutely. But we have specific terms for the two of them. What are the terms for the two of them? The dependent and the independent. Which one does which? Or which one does what? I couldn't hear you. Okay, the dependent is the one we don't change. What is the independent variable then? The one that we change. Okay, so then why do we even talk about a dependent variable? Okay, you have to keep something constant. Okay. So are there constants in experiments then? Somebody hinted at something that might need to be a constant in our experiment. What might need to be a constant in this experiment looking at goldfish? Okay, we gotta put them in water. I agree. They all need to go in water. What else might be a constant?
How fast?
Mr. Avery says how fast the gills are going. Is that gonna be constant? Okay, some people are saying no. You gotta be louder. I can't hear you. Size and the age, is that going to be a variable or a constant? Good point. So what we have done is we've got goldfish, and those goldfish are all relatively the same size and probably pretty close to the same age because they're pretty close to the same size. I think we've got like 14 of them in here. So we've got a bunch of goldfish, relatively the same size. We don't have big ones, we don't have small ones. They might be slightly different, but they're pretty much the same. So we have water as a constant. We have goldfish size and probably age as a constant. Are there any other constants that we might have? Okay, let's go back to the independent and dependent variables then. What is the one thing that we are changing in the experiment if we are looking at what relationship, if any, exists between the temperature and the rate of breathing? Ms. Markey. The temperature is the one thing we're changing. Who agrees? I've got about 50% of you with your hand up saying, yep, I agree. The one thing we're changing in this experiment is the temperature. Okay. I see a couple more hands come up. If the independent variable is the temperature, what is the dependent variable? Fish were constant, we said. They stay the same. Yes? Oh, the movement of the fish gills. So if we are changing the temperature inside of the environment, then we should observe a change in the movement of the fish gills. Who agrees with that? Okay. How are we going to go about testing this? What do we need to do? Mr. Jacob.
Put like one in a different, like a different egg, but different temperature of water.
Okay. If I put a fish in a different tank with a different temperature of water, am I keeping all things constant? Or am I keeping a constant that I should be? I didn't ask that question very well. What tends to change between the different tanks that we see in this classroom? Temperature might change, or maybe not, because they're all in the same room, right? They might be all pretty close to the same temperature, because I don't have any of the chillers running yet, so basically they just absorb energy from the environment, from the room. So their temperatures might not be much different. What else is changing as I look around the different tanks in this room? The amount of water. Oh, well, if I am putting a fish in a tank with a different amount of water and a different temperature, how many variables did I change? I changed at least 2, right? Not even accounting for the fact that the water chemistry might be slightly different in each one of these tanks because they've been sitting around for a while. So what do we need to do in order to make sure that we retain constants and only change one variable, being the temperature? Oh, we can keep them in the jar, or maybe I have some cups available that are all relatively the same size. And so we're going to add pretty much the same amount of water to each one of them. And we're going to use water that is directly from the tap for this activity, so then we know the water chemistry is pretty much the same. And our changes are not based on water chemistry, right? So I heard in this experiment, we are going to change the temperature of the water. We are going to keep it within the range of tolerances of like 55 degrees to 80 degrees Fahrenheit. We don't want to go below that, and we don't want to go above that. What tools do we need, and what measuring devices might we need? Yes, ma'am? Oh, we need a thermometer because we need to measure the temperature. Okay. Yes, sir. Okay, maybe having data on the size of the fish is important. Okay. We talked about that being a constant, so identifying that might be important. Yes, ma'am? We need what? We need access to water. That's definitely a tool that we need. We've got all kinds of sinks in here. Probably going to need hot and cold water to try to mix them to get temperatures where we want them. Okay. Let's think about experimental design. And let's think about how we go about designing this experiment. How do we want to make this experiment work? Where we make sure that we're all collecting the same information or doing the same thing. So that then we don't end up with a situation where Riley's experiment is extremely different than the Stinson's experiment, and then we really don't have a way to do a comparison. Yes, ma'am? Okay, let's make a procedure. Let's do it together. So I'm going to pull up on my computer a Google Doc, and I'm going to share my screen so we can all see it. I guess we're going to leave it in that account for right now. All right, so our procedure. Maybe we need to identify our independent, dependent variables and constants first. Did we say our independent variable was again? Water temperature. Dependent variable. Mr. Fisher? The mouth movement / operculum movement. What were some of our constants? Space, is that what you said? Oh, size of fish, okay. Age of fish. Amount of water. Type of water. We talked about water chemistry. All right, procedures. Then we also need to make a hypothesis. We want to make sure we do that before we get started. Procedures. Well, how do we want to do this? Yep, I absolutely can. I will make it. I'll just do this. I will zoom in. How about that? Is that better? Maybe a little bigger even. All right, procedures. So get a cup, catch a fish. Thoughts on this? I'm gonna go get my cup. I'm gonna catch a fish. Got one in each hand. And then I'm gonna what? I catch the fish in the cup. How did I get the fish in the cup? I just put the cup in there and scoop it up? Oh.
I don't know if it's a couple of it, but if not, you can like pour it.
No, just get it net.
Okay. Net a fish. It's what? I couldn't hear you. Oh, you gotta get water. That might be important. So if I got an empty cup and I've got a fish, well, that poor little fish is gonna be out of water for a little while until I can get some water. So I need to get a cup to start. And then I need to get water. How much water do we need to put in there? Okay. Fill cup with water to halfway point. Are we okay with that? Yeah. Oh, we have to turn the temperature of the water to where we want to put it. Okay, so should we just say check water temperature or record water temperature? And adjust if need be. Okay. Then what? Then we can catch the fish? We're okay then, catching the fish? Okay. And what do we do with that fish? And put it in the cup of water. Okay, check. We need to think about the time issue because I think somebody hinted earlier about the fact that, well, if I was to take the fish and just throw it in that cup and it's cold water and just start counting the amount of mouth movement right away, it might still be exhibiting the mouth movement from the previous temperature water. So do we need to let it acclimate for a little while? Okay, how long do we want to make our fish acclimate? 5 minutes seems like a long time to me. You think 1 minute? Okay. Let fish acclimate. Let fish acclimate to water for 1 minute. Now what? Yes, ma'am?
After the one minute is over, then we need to observe that this is breathing and
Okay. How long do we need to do this? What are we doing with that observation? You think just 30 seconds we can just look at the fish and be like counting it for 30 seconds? That leads to a different type of material. We didn't talk about this yet. We talked about needing a cup. We talked about needing a thermometer. And now we need something. We talked about needing water. Now what else do we need? Yeah?
a net.
A what?
A net to catch it.
We might need a net. What else do we need? a timer of some type, right? We're just now realizing that, hey, we need something to record time. So observe the fish's breathing slash operculum movements. And then we said we wanted to record operculum movements. For how long? For 30 seconds? I don't know. It's your experiment. What do you guys think? You think longer what?
I think longer than 30 seconds, maybe like a minute.
Okay. What do you guys think about that? There's been a proposal of 30 seconds, and then one of your peers says, maybe we should go just a little bit longer, more like a minute. I see some support from Fisher. Is there anybody else that would just rather go 30 seconds?
Yeah.
So we've got 3 people with 30 seconds, 3 people with 30 seconds, and 2 people with 1 minute. Is there anybody else that can support one of those 2 times, or maybe you're thinking longer? Ms. Stinson? Okay, so split the difference, 45 seconds. Megan? You're agreeing with the 45 seconds? An agreement with 45 seconds? Okay, I see a lot of people saying we're going to meet in the middle. I'm going to start walking your way, and you're going to start walking mine, and we'll meet in the middle. And so we're going to go 45 seconds. So we're going to record for 45 seconds. Okay? Then what do we need to do? Okay, maybe do it multiple times. Okay. Or maybe pick a different fish and then try a different temperature. Really, all it comes down to is just making sure that we're measuring temperature. Online folks, I need one of you to set up a data table for this, and I need you to share it with our whole class. So online people, I need a data table for what we are recording, and that data table needs to be shared with our entire class. Probably the easiest way to do that is for you to create the data table and share it with me. Give me editing abilities, and then I can take that document and just drop it on our class stream for everyone to get to. Questions, comments, or concerns? We have not done our hypothesis yet. We typically write a hypothesis in an if-then statement. If this happens, then this happens. Oftentimes, we include the independent dependent variable in that hypothesis. And so what is the one thing that we are changing? Temperature of water. So if the temperature of the water does what? Decreases, rises, decreases. I don't care which way we go. Somebody just needs to make up their mind.
Lower.
If temperature decreases, then what do we think is going to happen? Okay. Then operculum movements will decrease. This is your hypothesis. You don't have to copy this hypothesis. Maybe you think that if the temperature decreases, operculum movements increase. This is just a hypothesis that we put up there as an example. Ultimately, what we're trying to do is either accept or reject our hypothesis based on data. Okay? So at this point, we are going to transition into performing this experiment. There is cold water in the cooler over here on the side faucet. I will get thermometers out. Each one of your computers has a timer on it that you are welcome to use. We only have so many goldfish, so some of you might be sitting there recording other people's data. Maybe what we can do is we can organize this in a way where one person's counting, the other person is recording, And we said something about having replicates in data, and then maybe you switch. Maybe one person records and you count, so that then we can end up with a situation where we have an average or we identify those things. All right? Ultimately, what it is about collecting lots of data to either accept or reject our hypothesis. Questions, comments, or concerns? All right. I'm going to stop the recording.
Elizabeth died.